Thank you very much. So yeah, it doesn't start well because I'm going to say that there is no such thing as artificial intelligence if the clicker works. This is technology, right? I'm confident. Do you have to do something? You have to push a button somewhere? Yeah, that's me. So this is the guy with the, Hawaiian shirt. I see that I'm the only one again. Anyway, so there is no such thing as artificial intelligence. What does that mean? I mean, of course, I'm doing artificial intelligence for the past 30 years, so it means that I didn't do much. Or it means that we didn't, use the term artificial intelligence correctly. And I think that it's more the way it is. Artificial intelligence, the way it's being seen, for the past, let's say, 10 years, is something like what I call the Hollywood artificial intelligence. So this is the one, that is a myth. This is something that, it's Terminator, it's Her, it's all those movies that, make us afraid of it or, make us dream about it. So I'm going to show you today that artificial intelligence is not that, okay? This is not what artificial intelligence is, so this artificial intelligence doesn't exist, okay? The one that exists is the one that exists for the past 60 years plus. And we can start by giving a definition of artificial intelligence. And the definition was actually made or done by some people in 1956 when some scientists back in the University of Dartmouth in the States met and decided to call what they were working on artificial intelligence. And what they were working on was, mathematics, basically, statistics. And they said, okay, we are building a brain. We are building a brain with, numbers. So they said, I can model with simple statistics. I can model a neuron. If I have a neuron, I have a neural network. If I have a neural network, I have a brain. And if I have a brain, I have intelligence, which is totally stupid. Because, of course, it doesn't work like that. And, it actually showed that it was stupid because they failed. And I'm going to go back to that. But let's think about what they wanted to do. They wanted to do a machine, basically. They wanted to have a machine that is going to perform some tasks that are going to look intelligent. But when you think about that, I mean, human beings, they are doing that for thousands of years, okay? So this is what we are trying to do. We are trying to delegate those tasks to machines, right? And I can go back to antiquity, I can go back very, very far, but I'm very, very French as well, so I'm going to go back only to 1642. What happened in 1642? Pascal, the French philosopher and mathematician, invented the Pascaline. The Pascaline is the very first calculator, right? It was doing very well addition and subtraction. And, doing addition and subtraction is smart, right? It's very smart, it's very difficult. I'm going to say, no, it's not that difficult. But, it was doing some 4 digits addition and subtractions. If I am asking right now, how much is 1598 plus 472? Okay. So by the way, the machine in 1642 would have gotten the result in less than 4 seconds, right? I didn't get any. So I don't know if it's because you are not intelligent. I don't know, maybe. Or maybe shy, yeah. But in any case, I mean, even though you were going to give me an answer, because it's you, because it's us, humans, the answer would have been wrong 60% of the time. The machine is always right. This one was always right. It was mechanical, actually. It was very easy. You turn the wheels, and it carries the numbers correctly. I mean, it does very well. So anyway, so we were trying for, years to do those machines. And so I want artificial intelligence to start in 1642. And to come back to my friends, they are in 1956. They actually, as I said, they failed because they tried something that was the most difficult thing that you can try maybe, because they decided to tackle natural language. What is natural language? This is what we are doing right now. Somebody is talking, there are words, and you are trying to catch the words, but you are going to try to catch the meaning. And the meaning is the most difficult thing to get because, it depends on the accent, it depends on the context, it depends on a lot of things, and they failed. They didn't succeed to create a robot, to create an artificial intelligence that was going to recognize everything. And even today, if you're using Siri, Alexa, or whatever, it's still very, very complicated, and it's still not working very well. So they failed, and it was an issue actually that they failed because they promised a lot of things. They promised, that they were going to build this artificial intelligence that was going to be, wonderful, doing some incredible things. And we entered in 1960 something that we call the winter of AI. The first winter of AI, because there have been several since then. But the first winter of AI was basically, no more funding, no more research, no more AI. And we need to be careful, that it doesn't happen again now. Because we are promising so many things with AI that if we don't deliver, we are going to deceive a lot of people, and we are going to stop this thing that we shouldn't, because I'm going to show you that there are a lot of AIs, and not one, but a lot of AIs that we should continue to work on. Anyway, let's give a little bit of history and see what happened, next. So, winter of AI, this statistical AI that appeared, back in 1956, disappeared altogether, gone. A new one started, to come, and it was called the expert systems, basically. This is a logical AI. Expert systems, pretty easy, rule-based. If blah, 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 then blah, blah, blah. Pretty easy. You can do a lot of very, very interesting systems with that are working very well. And it was working from the 60s to the 90s, basically. A lot of expert systems, And it's very, very interesting. And one of them that was very good is the one that actually beat the world champion of chess, Kasparov, back in 1997. Right? Very impressive. It's very intelligent to play chess, right? No, okay, that's fine. It is not bad. So, so the machine was actually beaten. Chess is pretty interesting, but actually it's pretty easy, right? With all the quotes that we have to put, right? But chess is only 10 of the power of 49 moves. So it's not a lot of moves. Some moves. But it's based on rules. It's a game, and the rule-based expert system, of course, can play with that. So it's actually pretty easy to play. And today, if you have a system that is playing chess, you cannot beat it. I mean, if you try to beat a machine, it's because you put it at level 2, okay? So you have no chance. Anyway, so it was pretty impressive. And expert systems were very, very good. And by the way, we forgot expert systems, nowadays. We should maybe, for reasons that I'm going to go to later, we should maybe think that sometimes it's simpler to use those systems than the ones that we are using today. Because today, something reappeared in the 90s, and the thing that reappeared in the 90s was, again, this statistical AI. We gave it a new name, and we call that machine learning. It's very impressive, so the machine is going to learn, and it's going to learn with data, right? And it's going to need a lot of data, and this is what we are going to talk about, of course. And, it was in the 90s, basically, that it came, and because it came back because of something that, appeared in the 90s that you might remember, and it's called the internet, And the internet came with a bunch of data, a lot of data. At the time, at the very beginning, the internet was actually pretty good because you could maybe trust the data that was on the internet. It was back, in 1995. Today, I don't know. So anyway, so the internet came up and lots of data. And then, in the 2000 years, even more and more data. And more data means, new thing that is going to be called deep learning, and we are going to feed those machines with data and data and data. And the first types of data that were on the internet were cats. images of cats, pictures of cats, lots of cats. People were posting cats, saying, this is my kitty, this is my little cat, this is catty, well, whatever. Okay? So we had the biggest database of cats in the world. And of course, people said, okay, I'm going to create with that a recognizer of cats. I'm going to be able, to create a machine that is very smart, that is going to recognize cats. Wow. We created something in 2000, 2005. We created some recognizer of cats that were able to recognize cats at 98% of accuracy. Wow. That's artificial intelligence, right? 98%. With only 100,000 images of cats, we're able to recognize cats. Wonderful. And now you ask yourself, but my 2-year-old daughter, how many cats does she need to recognize cats 100% of the time? So the psychologists are going to tell you she needs 2. After 2 cats, she's able to recognize cats, 100% of the time. Even cats at night. That the recognizer of cats, the one that we built, the machine learning one, it wasn't able to recognize cats at night because nobody posted an image of a cat at night because we don't see it. Okay? So here, there is an issue. It means that we are building those machines with a lot of data, and we realize that they have nothing to do with our brain. 100,000 images of cats against 2, right? And to go further, in this direction, let's look at what happened 10 years later in 2016. 2016, this is the world champion of Go, who is being beaten by the machine. Go is much more complex than chess, right? If you ask mathematicians, they are going to tell you that there are between 10 of the power 200 of 10 of the power of 600 moves at Go. 10 of the power 600, 200, it's a lot, right? And basically, we don't know because the difference is huge. But let's say that it's a 10 of the power of 200. 10 of the power of 200 is not only 4 times more than 10 of the power of 49, right? Okay, that's fine. That's mathematics. So it's a lot. Basically, it's infinite. It's a lot. This is something that we cannot grasp. And so we were not able to do a machine that was going to play Go. We were not able to use the same techniques that we were using in 1997. So we were not using an expert system. We are using machine learning and deep learning. And when I say we, it's actually DeepMind, the machine that was running AlphaGo. This is a subsidiary of Google basically doing that, right? So very impressive. The world champion, 18-year-old, Korean guy, beaten by the machine. And, it's pretty good. But the question is going to be the same as what I asked before. Let's look what is inside the machine. I'm not going to look at the algorithm. I'm going to open, the guts of the machine and to look what is inside. By the way, the machine doesn't look like that. This is my drawing, okay? So when you open it, you find about 1,500 CPUs. CPUs, the chips that are in computers. 1,500 CPUs. You find 300 GPUs. GPUs are, the better CPUs, if you will, that are going to do matricial calculation, very good for machine learning. And another type of chips that is called TPUs, specifically for TensorFlow. If you know what TensorFlow is, this is a method to do deep learning. So anyway, it's about 2,000 computers. 2,000 computers to play Go. Okay? 2,000 computers. It's 440 kilowatts. 440 kilowatts to play Go. And the question is, what is that there in terms of watts? What is it that we have, when we play something, when we do something? We have that. Most of us. It's about 20 watts. 440 kilowatts against 20 watts. It doesn't make any sense. We are using all this energy to, look at the data, create the models, and do, doing the inference and stuff. I mean, this is a lot of energy. So we need to be very careful when we say that we are creating those machines that are intelligent, and we have to realize that they are not efficient. We use a lot of energy to process those data. So we need to be very, very careful when we create those machines. At one point, especially right now, in this context, of the world, we realize that energy is not free, okay? So we are going to have to choose at one point. We might have to regulate at one point those AI because they are using way too much energy today. Anyway, let's go about, talking about data. Because of course, this is what the meat is. This is data. And there is some bad news actually about data. As I said, at the beginning of the internet, everything was flowery, everything was nice. I mean, the data was good. Today, as you know, there is fake news. There is, a lot of bullshit on the internet, and you cannot really trust the data that you find on the internet. I'm sure that today, if I'm looking for a cat on the internet, I'm going to find a dog, right? So this is an issue. Data is biased. Data is always biased. So I'm going to give you an example that is coming from 2016 as well, when Microsoft released a robot, a chatbot, on Twitter, okay? And they released a chatbot that was called Tai, and the goal of the chatbot was just, to chat with people on Twitter and to promote the Microsoft product, very good idea. They spent most likely a lot of months, developing the thing, and then they released it on Twitter. They released Tai, and they unplugged Tai after 16 hours of operation because Tai was the most racist and sexist, robot, chatbot in the world. Of course, they didn't want that. Of course, they didn't develop, things that are going to unplug after 16 hours. It doesn't make any sense. So why? It was the question, why? What happened? Of course, they didn't, talk about it, but a lot of scientists, look at it and made some hypotheses about it. And there might have been two issues. First one, we are going to call it a logical bug. Pretty easy to fix, but it's a bug. So what is the logical bug in this case? When you create a chatbot, when you create a dialogue system of some sort, you need to basically communicate with the audience that you are going to communicate with, right? So you need to go to the level of the audience, right? So you have a slider that is called an adaptivity slider, where you adapt to the audience. And so if it's high, it's adapting a lot. If it's low, you basically, keep the dialogue, the way the dialogue is going, and so you decide how it's going. Here it was a little bit too high, so it was adapting too much to the Twitter audience. And as you might know, on Twitter, after 2 or 3 interactions, you insult each other. So it was working pretty well. The system was insulting people. So this one, easy to fix. You lower the slider, and you get, to control the way the system is going to work. Easy. The second one is going to be a databag. A databag is going to be something where, the data on which you train the system, the model, is going to use the wrong data. And in this particular case, again, when you create a system that is a dialogue system, you need to have, some dialogue examples. Like you need to have some cats, to recognize a cat. You need to have a dialogue to recognize or to manage a dialogue. And there is not a lot of dialogues that are annotated and that are clearly defined as dialogue on the internet. So you go somewhere else. It happens that there is a database that exists since the 50s in the States that is called Switchboard, that is a database of dialogues. So basically, what is it? It's a lot of people who are making phone calls to whatever, to call centers and talking about their washing machines, their I don't know what, and all those dialogues, they are being recorded, they are being transcribed, and they are being annotated. So you have the transcription of the dialogue, and the dialogue. You are also saying, the guy was pissed off. It was a nice conversation, whatever. So you have a nice database with millions of conversations. So this is what usually, people who are creating dialogue systems, they are using switchboard. So most likely they use switchboard, but they didn't need actually millions of conversations. So they took a subset. And when you take a subset, you have to make a choice, and they didn't think much. And they said, okay, let's take the start of the database. I'm going to take, the 50s Alabama. 50s Alabama, can imagine that if you are a black person, maybe it's not that good, right, for you. So maybe the model was twisted, at the beginning, and you didn't need much to basically spark, the system to be racist and sexist, because why not? So the issue is that, those data, as I said, they are going to be always skewed. They are going to be always biased. And the issue is that you are going to say, okay, but I know it's biased, so I'm going to be careful. I'm going to choose the data. But as soon as you are doing just that, you are entering your own bias in the thing, right? Yours, or the ones of your company, or the ones of your country, or the one of the whatever, right? So this is a very, very tricky problem. I'm not saying that I have a solution, but this is an issue. This is an issue with those AIs that we are, working on today, deep learning and machine learning, because they're all based on data, and a lot of data, and it's impossible to control the data. Or if you control the data, you are creating a system that is not the real thing. Anyway, you have to think about that. And there is another thing that we say when we talk about AI. We say AI is a black box, right? So AI is a black box because we don't know what is happening inside. We cannot explain it. It's difficult, blah, blah, blah. So I'm claiming today that AI is not a black box. I'm claiming that AI is actually something that is very explicable by the people who are creating the AIs. Because the people who are creating the AIs, they are going to choose the data, as we said, so they know what they are doing, more or less. They are going to choose the algorithms that they are going to, put against the data. And they know pretty much where the system is going when they are creating those systems. And by the way, this is what is happening in all the sciences all the time. There is at the beginning a very small set of people who understand it until it's being explained. And I'm saying that we can explain everything. And I'm going to give you an example of a mathematical system that was discovered in 1914. There was a guy who was a mathematician, a French mathematician, of course, who was called Gaston Julia. And Gaston Julia was, a pretty good guy. And in 1914, he discovered what we call the fractals. So people who know what the fractals is, you have right now in your mind something. People who don't know what the fractals is, go to Wikipedia. So 1914, Julia, they discovered this equation, basically, that had a very specific property, right? And so he discovered that, he showed that, he wrote a paper, he showed that to the community of mathematicians. The mathematicians were all excited because mathematicians were specialists, on those kind of equations, and they understood it. There was no black box for them. But for most of the people, when they were looking at the equation, it was a black box, totally uninteresting. Yeah, it's a mathematical equation. Okay, and what? Then in 1955, 40 years later, Julia was professor at a French school that's called Polytechnique, and he had a very good guy from Poland, who was a pupil, a student of his, and his name was Benoit Mandelbrot. And Benoit Mandelbrot, listened very well, understood the equation, and he went to the States, to IBM, and he was given a machine, one of the first computers. And he said, okay, I'm going to enter the equation, I'm going to plot it. I'm going to, look, what is this equation? Can you visualize it? So he entered the equation in the computer. He called it Mandelbrot set, instead of Julia set, that's fine. No, I'm not pissed. And so appeared on the screen this beautiful drawing that people who knew what a fractal was, had in their mind, which is showing that at every, single piece of the drawing, this is the same drawing, and the same drawing, and the same drawing. Recursivity was the property of this equation, okay? And when you see it, you cannot miss it. It's obvious. So the black box for everybody became totally, transparent. So I'm not saying that in 40 years, we'll be able to have, all the AIs that will be transparent boxes. But if we want to, if we take the time to explain, if we take the time, to just learn, AIs can be totally transparent. And then you can trust them, but you will know more about that tonight. So, okay, since we are talking about stuff that pisses me off, Mandelbrot, Julia, you got it? I'm going to talk about autonomous cars. Autonomous cars. 2018, Elon Musk, the guy, decided that autonomous cars were coming tomorrow. 2018, CES 2018, Las Vegas, January. Autonomous cars are coming tomorrow. It's going to be great, it's going to be everywhere, and only autonomous cars. Great. 2019, autonomous cars are coming next year. It's coming, yeah, it's great. 2020, autonomous cars are coming in 5 years, about. 2021, autonomous cars are coming in 20 years, approximately. 2022, it's going to be tough. It's going to be tough, but it's coming. It's coming, guys. Okay, so since 2018, the very first day, he said this thing, people who are, in the system, they are saying that autonomous cars will never happen. Read my lips, never. Talking about autonomous car level 5, not talking about autonomous car level 3, 4. Those ones are coming. Actually, we are almost at 3 right now. Right now, most of the system, most of the people who are doing autonomous cars, they are the ones who are doing cars like Tesla, or there are some that are doing systems like WeMo, 2.5, 2.7, this is where we are, okay? Level 5 is the maximum autonomy. This is where you just put a car somewhere and it goes from A to B, no issue, and hauls everything, and it has no accident, of course, nothing. Level 3, something that is going to be very safe, but you still need to have your hands, on the wheel at one point, because you are going to have to help it. Level 4 is going to be mostly autonomous. So most of the time it's going to drive by itself, but sometimes it is going to need help. It can be help from inside, but it can be help also remotely. So maybe there will be some level 4 cars that will not have wheels, okay? So, but it will need help. Level 5 will never exist. And of course, you can believe me or not, but I'm going to prove it. There is 2 proofs that I can give. I mean, there is one. I don't know if people are familiar with Paris. There is a very known square in Paris that is called Place de l'Étoile. Place de l'Étoile is about 10 big avenues coming to the Arc de Triomphe, and when you are not in pandemic years, at 6 p.m., this place is a mess. Basically, gridlock. Know it, right? So that's just impossible for a human being, or it's possible because they go, but it's very difficult to navigate, right? And there is one thing that you don't do. You don't follow the rules of driving. You follow the rules of the jungle, okay? And so the issue with autonomous cars is that they do follow the rules of driving, and that's good, okay? So if you put one of those autonomous cars at the Place de l'Étoile, it's going to be stuck for about 3 or 4 hours, okay? It won't move, can't move. The humans, we can move because we have the power of negotiation. We have several ways to do it. But, this is a way. So anyway, I'm just going to a more international proof. And this one was done actually by WeMo. WeMo in 2018, the CEO, the previous CEO of WeMo, he said when Musk was saying, those things, he said, okay, guys, that's not true. I mean, it's not going to happen. Let's work towards 4, and forget 5, because it won't happen. But I'm working on going to 4, and I know that there are issues, and I'm working on that for 10 years now. And I have about 10 millions of hours of videos, of miles of videos, that I can share with the community. And I'm going to share it. In order for the community to go faster, I'm going to give my data. He gave up 10 million miles of recorded, driving time. It was incredible. And he put that on YouTube for everybody to access it. Now, of course, people like myself, I jumped on YouTube, to go to see the data. And I was looking for one thing, what I call a gem, that is going to be the proof that I'm right, that it will never happen. And 10 million miles of video, it's a lot of videos. I didn't need, a lot of time actually to find one gem. And there are many, many of them. And what is the gem that I found? It's actually a car driving, we see there is a camera that is behind the windshield, and you see a car driving in the streets of Mountain View. Mountain View is the place where Google is. And so you see this car driving in this street. I don't know if you know Mountain View, but Mountain View is boring. Nothing happens, right? It's not the Place de l'Étoile. So anyway, so the car is driving like that, and for no apparent reason, in the middle of the street, stops. It waits 2-3 seconds, 2-3 meters, stops. 2-3 seconds, 2-3 meters, stops. Does that 6 times, and then you see that the safety driver, there's always a driver in those cars, takes the wheel back, and leaves, because behind him, people were kind of upset. Why does this car stop in the middle of the road like that? Doesn't make any sense. It makes no sense until you look at the video a little bit closely, and you see that they are on the sidewalk. There are 2 guys walking in the same direction of the car. Okay? And when you look even closely, you see that the guy that is on the left side of the sidewalk, next to the street, on his shoulder, he has a stop sign. You see a guy on the side of the street walking in the same direction that you are doing with a stop sign on his shoulder. You don't stop. If you do, come to see me. So you don't stop because you can invent, you can adapt to something that is not possible. This is just unbelievable. This is just something that doesn't exist. This is just something that doesn't happen. But it happens. And when it happens, we adapt. The AI, the smart car, the autonomous car, saw a stop sign, and a stop sign, and a stop sign. So this kind of improbable things just show that autonomous cars will never happen. Just impossible. Of course, today, most likely the engineers, of WeMo or the engineers of whatever, they added a case that says if there is a jerk on the side of the road, with the stop sign, then go. But it's dangerous because you never know if it's a guy that is, monitoring some kind of road work or something. So anyway, very complicated, will never happen, but level 4 will be incredible. Level 4 will happen. I'm not going to give you a date. I'm not Elon Musk. So I'm not going to tell you that it's going to happen in 10 years, 20 years. I have no idea. Level 3, we are very, very, very close. Level 4 will take some time. Level 5 will never happen. Okay, so that said, I want to talk about Siri. Siri was fun. It was cool. 500 million people using it, but it was a joke, basically, in the sense that it doesn't work. And it is because it doesn't work that it worked. Yeah, let me explain a little bit. So, when we created it, we knew that speech recognition didn't work. And meaning recognition, what we call natural language processing, it's even, more complicated. CF, what those guys were trying to do in 1956. So basically, it doesn't work. It's very difficult. But we knew that. And instead of saying it works, it's going to work, like Elon Musk would say, we said, since it doesn't work, we are going to make Siri fun. And when Siri doesn't understand, she's going to deliver a joke. She's going to make you, smile, and it's good enough. 500 million users. Okay. So I don't like to talk this thing, to call this thing artificial intelligence. I prefer to call that augmented intelligence. It's still AI, right? But the augmented intelligence is us. It's not a domain. Those things, those artificial intelligences, they are going to augment ourselves. You have to look, if you want really to talk about artificial intelligence is going to be a toolbox. A toolbox in which there are going to be a lot of tools, like in a toolbox. It's going to be a screwdriver, a hammer, it's going to be, a saw. A lot of different tools that are specifics, that are specialized. This is exactly what artificial intelligences are. They are specialized in very specific things that are much better than us, each of them, because the tool is much better than us. Otherwise, it's not a tool, right? A hammer works pretty well. A hammer, when you want to, drive a nail in the wall, it works better than your fist, right? But the hammer, I can use it the right way, drive the nail, in the wall. I can use it the wrong way, tap on the head of the guy in front of me there. Not good. But why do we know? How do we know it's not good? He knows because it hurts. But, us, we decide collectively that it's wrong to use it like that. The AIs, it's exactly the same thing. The AIs, they are just tools that, Alexander actually said that, at the beginning, that we are going to use. We are going to decide how to use them. But they are very powerful tools. They are going to be better than us, in any case, right? So they're not going to be geniuses. They are going to be the geniuses when they play Go, because they are going to beat us all the time. They are going to be geniuses when they play chess, because they are going to beat us. They are not going to be geniuses when they drive a car, okay? So we decide how to use those things. We have to be very careful because they are very powerful. It's hammer plus plus, right? But the good thing is that we have the handle of the hammer in our hands. We decide. AIs do not decide. This is not Hollywood. Thank you very much.
I think we can spare a few minutes, 5 minutes. So if there are any questions, I do have a couple to begin with. First of all, 2070, am I right? The edition that you were asking for.
So that good?
2070.
2070, what happened?
You asked the question about, I think it was, I wrote it somewhere, 5098 and 4072.
Sorry.
Yeah, but that's another. I don't think you're fair to this guy. I mean, you're saying that he's wasting 440 kilowatts,
Yeah.
while this guy, you're only counting his 20 watts.
No, I
But basically,
counted-
he's representing 160 gigawatts of human brain power.
18 years by 20 watts.
But his brother,
Yeah,
his
yeah.
brother won't be the same champion, and his brother will be the same. I mean, another computer will have the same power as this first computer. Well,
that's
we don't
true.
know about this guy.
The
Are we
issue is that
expecting the question is, are
Yeah.
we expecting
Yeah.
too much from these guys while we are glorifying this guy for doing one thing good?
Yeah. So, yeah, I mean, the issue is that, with the world of today, it's actually not 440 kilowatts anymore, it's more. Because it's always more. This is a race where we are adding more data all the time. And when you look at something like right now there is those generative AIs that are very, in fashion. Generative AIs, they are using a huge amount of power and processing power. So we need to be careful because we are entering a race that actually we shouldn't do it. We should think about optimizing those machines to look a little bit more like ourselves instead of entering this race, because this race is not going anywhere but in the wall.
War with machines. You mean the war with machines or war between us using the machines?
No, the wall in front of the machines and the wall that we are in, that is
Oh,
called
you mean the
planet.
wall? Sorry.
The wall, yeah.
The wall. I mean,
the planet, is something like a finite thing, and we are going straight into the wall today. We do not have enough energy to handle this kind of machines.
Speaking about the planets, we do have autonomous cars presently working,
No.
but not here. They're working on Mars. So we can say that the only problem with autonomous cars are people.
Yeah, so you're kind of right. So the good thing on Mars is that there is not a lot of traffic.
And there are no traffic signs.
Yeah,
So
so-
he has no problems. I mean, why would they need traffic signs?
Yeah,
I mean,
yeah.
because he can speak with sensors and stuff that we don't
Yeah,
see.
when there are 2 of them, 3 of them, 5 of them, yeah. When there are, millions of them, it's more complicated. But let's see. I mean,
But it's visible.
no. So let's talk about that very quick. So there are people that are saying, yeah, but the day there will be only autonomous cars, it will be a perfect world because, they will speak to each other, blah, blah, blah. Exactly what you just said. There's one issue. It's cats. Because there will be cats on the street, because there will be humans on the street, because there will be bicycles on the street. There will be things that are not autonomous. And they are going, and we see that, for instance, in Arizona today, where WeMo is operating. People are on purpose, they are getting in front of those autonomous cars, just to make them crash, basically, and it's funny.
It's a strange hobby.
Yeah, it's people. The issue is us,
So Mars
So
is,
just
Mars
remove
is
the
good.
people. Mars is good, there are no people.
Questions.
As far as I know. I mean.
Questions, I think. Okay, one question. Do we have a mic? Sorry. So we can all hear. Here, please.
See, the possibilities of all the solutions, like whether it's possible or not possible, depends on our current understanding of the technology. Say, for example, 300 years ago, many people said that it is not possible to fly at all, right? So today also, some of the impossibilities which we are saying is given the current knowledge we have. Now, we don't know what knowledge we'll have after 20 years, so maybe...
You're right. And one thing that I didn't say is that here I'm talking about mathematics. I'm talking about the AI based on mathematics. I don't talk about AIs based on something else. Biology, quantum thing, that I don't know. So you're right. Maybe one day, the AI will be much closer than, the biology that is inside. But I don't know that. The thing is that today mathematics is coming from our mind, right? We create mathematics. And so this is where it cannot work. The day we will be able to understand what is up there, then it's good. But today, if you ask people, who are working on the brain, how much do we know about our brains? It's about between 20 and 40%. So we still have a long way to go.
So it is only 8 watts. Any other questions? Okay, my final question is it going to be, I mean, can we count that artificial or augmented intelligence would be the right thing if we can make it laugh?
Yeah, this is what we try to do with this guy, you know. So I mean, you're right that one of the issues, and we see that, is to copy emotions. Everything that is going to be non-tangible is something that those guys don't get. They don't have any empathy, those AIs, right? Because empathy, what is it? Depends, you know, all of us. This is different level of empathy. So how do you program empathy? So this is something that is very, very thing. So everything that is not tangible.
So if they can create a joke, we should start worrying.
Yeah, but they won't create it. And this is the thing with artificial intelligence that we are talking about today, the generative artificial intelligence. People are saying that they are creating. Those generative AI, they are not creating. The guys that are the creators are the guys that are creating the prompts that are going to use the tool that is creating the stuff. So the generative AIs, they are not creating anything. We do.
So that is the difference between them and us.
Yeah,
Creation.
We are, I would say, innovation, creation. We are the best, and we will still be the best for a long time.
Thank you.
Thank you very much.
Thank you, Mr. Luc Julia.